Okay, so again, we're going to use something called the solubility rules to determine if a salt is soluble or not. Okay, and how we read this chart. So there's a whole bunch of different charts you're going to find out there on the internet. You can look up solubility rules on the internet, and you'll find a whole bunch of different charts like this one. You'll find a whole bunch of different rules. Okay, I find that this one is one of the simpler ones to use. Okay, it does not include everything out there in existence. Okay, but it includes all the ones that I'm going to give you. Okay, it's just kind of a little bit of practice. See if you can figure out how to do this kind of stuff. Okay, so basically, what you're looking at here is this part here says soluble compounds. Okay, so soluble compounds. Well, anything that has a group 1 metal. So group 1 is the first column metals. So the alkali metals. So anything that has a alkali metal or NH4 plus. So this is the ammonia. This is the ammonium cation, the polyatomic ion ammonium. If you see any compound with either a group 1 metal or NH4 plus, you know it is soluble. There are no exceptions to that rule. Okay, so it's soluble no matter what. Okay, same goes for nitrates and acetates. If you see any compound with a nitrate or acetate, those are soluble. Okay, there are no exceptions. There are no insoluble exceptions. Chlorides, bromides, and iodides, they are generally soluble. However, there are some exceptions. If you have a chloride or bromide or iodide with silver, lead, or mercury, those are not soluble. They are insoluble. They are not soluble. So you have AgCl, that is not soluble. If you have AgBr, that is not soluble. If you have PbBr2, that is not soluble. HgI, that is not soluble. However, if you have anything else with chlorides, bromides, or iodides, those are soluble. Okay? For sulfates, sulfates are generally soluble. Most of them are soluble. However, there are some insoluble exceptions. These are all the exceptions. Ag plus, Pb2 plus, Hg plus, Ba2 plus, Sr2 plus, and Ca2 plus. So there's a lot of exceptions here. So silver sulfate, lead sulfate, mercury sulfate, barium sulfate, strontium sulfate, and calcium sulfate are all insoluble. However, all the other sulfates are soluble. Okay, so if you have ammonium sulfate, it's soluble. If you have sodium sulfate, that's soluble. If you have lithium sulfate, it's soluble. Okay. Now we move down to the insoluble compounds. Insoluble, so carbonate sulfites, SO2 minus, and phosphates, PO4 3 minus, are generally insoluble. The exceptions, though, are group 1 metals and NH4 plus. So if you have a group 1 metal, so sodium, lithium, potassium, if you have a group 1 metal with any of these things, it remains soluble. If you have ammonium with one of these things, it remains soluble. But if you have it with anything else, it's going to be insoluble. It's going to be insoluble. Hydroxides. Hydroxides are generally insoluble. The exceptions are group 1 metals again, NH4 plus again, and then Ca2 plus and Ba2 plus. There's a lot of exceptions there. Okay, sulfides are generally insoluble. Okay, however, there are exceptions, the soluble exceptions. So the soluble exceptions are group 1 and 2 metals and NH4 plus. Basically, sulfides with transition metals are insoluble. Okay, any transition metals, group 3 through 12. they're insoluble. However, if it's group 1 and 2, they are soluble. Oxides. Oxides are generally insoluble except group 1 metals, NH4+, Ca+, and Ba2+. Okay? All right. So those are the rules. How do you use them? Well, we look at a chemical formula here. We have NH4, C2H3O2. So this is an ionic compound here. We have ammonia or ammonium and the acetate ion. So we have two polyatomic ions here. We have ammonium acetate. This is ammonium acetate. And we know from the rules here that all ammonium compounds, they are all soluble. So that would be soluble. Okay, soluble. Barium hydroxide. So this is barium. This is hydroxide. Barium is in the first two columns, right? So it's just barium hydroxide. We don't need to write the Roman numerals for the name, if you recall. And then hydroxide, OH. Now it says here that hydroxides are generally insoluble. However, group 1 metals, NH4+, Ca2+, and barium are soluble. So this one is soluble as well. So that's how you're going to do it. You're going to kind of look, starting here. You just look at the cation. Really, it actually looking at the anion. Actually, the anion helps too. But the cation, anion. The cation is barium. It is a group 2 metal. There's nothing about group 2 metals in the first part here. And then we look at the OH. OH is here, hydroxide, OH minus. Okay, and then we look at group 1, NH4, Ca2 plus B8. So it is soluble. Okay, so that's how you're going to kind of attack this here for this entire chart. Okay, now if you have trouble remembering how to name the compounds, okay, if you have trouble remembering how to name the compounds, I did include the instructions for naming. You don't have to do this worksheet. We did this worksheet a long time ago, right? But I put the instructions up here so it can help you remember. And all of these compounds, they're not going to be covalent. None of these are covalent. They're all ionic or polyatomic. Okay, so they're all ionic or polyatomic. So you're going to follow the rules for ionic and polyatomic, naming ionic and polyatomic compounds. Okay, so that should help you name them or write the formula, because some of these I gave you, you have to write the formula for something like cesium sulfate, right? Okay, so that's the first part. Make sure you just, like I said, this is not a lot of work, but I'd like you to just take your time and do it right. Okay, take your time and do it right. Look over the rules for naming the compounds. Make sure you understand it. Make sure you work on the solubility rules. Just take your time and do it right. Make sure you understand it, okay? I don't want to give you a ton of work on this. I just want you to understand the ones that you're doing. Okay. All right, the next one. At the bottom here, you're identifying two new compounds which form if the solutions were mixed. So this part here, what you're doing, if you have AgNO3 and KBr, so those two, they match up right here, right? So AgNO3 and KBr, you're having a double replacement reaction. So Ag is now going to be with Br, so you get AgBr. And then K is going to be with NO3, so you get KNO3. Okay, so you're just switching. Remember, you switch the cation goes with the anion. So AgBr and then KNO3. So you're just switching the first part of each one. So for example, here you have AgNO3 and Na2CO3. So you're going to have Ag, and this is going to be 2 CO3. The reason you have two Ags is because CO3 carbonate is a -2 charge. And we know it's a -2 because sodium is a +1 and we have two of them. Okay, plus you can look at the chart here and you see CO3 minus is a 2 minus. CO3 2 minus. Okay, so you can see that there. So, and we always have to balance the charges. So Ag is a +1, CO3 is a -2. So 2 silvers, 1 carbonate. Okay, so we're going to have that as one product. And then the other product will be NaNO3. Okay, and then you want to tell me which one is soluble and insoluble. So instead of circle, you can just highlight. So highlight anything that's insoluble. So here we have carbonate. So nitrate, all nitrates are always soluble, as well as all uh, group one elements are always soluble. Well, let's look silver carbonate. So carbonates are generally insoluble. There are some exceptions, group 1 metals and NH4+. Silver is not a group 1 metal, it's not NH4+, so this is insoluble. So the silver carbonate is insoluble. So we're just going to highlight it. There you go. So that one is insoluble. So instead of circle, just highlight. Instead of circling, just highlight. Okay, again, so you're just switching, just combining this one, and then barium chloride with potassium bromide, just switching them, okay, and then determining if there are any insoluble compounds formed. And that's it. That's all you have to do today. So just take your time, okay? Just do it right. Make sure you understand it. Review the rules on writing and naming compounds if you need to, okay? And that's all you got for today. All right.